Okay, let's get started with today's session. Today we'll be discussing about ECS and ECR. So these two are the AWS services which is provided to manage Dockers inside AWS. Okay. Now, before that, if I directly go and create a container or go and create ECR registry, and if I create a task definition and if I execute the task, those who are not from Docker's background, you will not understand what exactly this container it is and why, what is this image, what container, what we are executing here and all. So what I'll do is today our today's session would be around one and a half hour. So first 50 minutes to first 30 minutes to 40 minutes, I'll explain about Dockers. Okay, so we will see what exactly Dockers is without AWS, how the Dockers will work. Later we will discuss what are ECR and what is ECS. Okay. Before that, so first you need to understand how exactly the Docker architecture is. If you see here in the earlier architecture, right, in the first image here, this is a bare metal system. What we see. So for example, it might be a computer or it might be a laptop, right? So you will have your server and you'll have a simple operating system, and on top of operating system you will have the libraries, and you will be installing all your applications. You will install multiple applications, 1 2 3 like this. So this is your plain system or a bare metal system which we are using in our day-to-day life. Later what happened, we got VM, virtual machines. So virtual machines are something like you will have same operating same hardware for multiple systems. So here the server host is same, whereas hypervisor software is there, which is like VMware or Microsoft hypervisor software. So what this VMware will do, it utilize the same infrastructure, I mean the same infrastructure of the host, and it will be creating a different guest operating system. So for example, here Linux, or here Windows, here Ubuntu, or here you can based on the system you can do SUSE Linux like this. So in the same mission, now this is given as one mission to us. This is what we are using in AWS, right? In AWS we can see when you are launching a mission, so we can select different type of missions like Linux, Ubuntu, Windows, or SUSE, or any other operating systems as well. So once you access to your VM, then what you will do inside your VM, again you will do the same thing. Like from here it is common, right? What are the libraries and what are the applications? So in one VM you will be running one or more applications. This is virtual machines what we know. Now let us see what exactly Docker is. So Docker is something like which is similar to virtual machine only, but the advantage of Docker is, so you after having the hypervisor, right, then you will have only single operating system. Means once you let's assume till here it is a VM1. So here Docker as a software will be installed. Okay, what this Docker software will do, it will not install again a guest operating system on top of this one. Okay, guest operating, we know, right, operating system is a one of the major chunk which will eat up a lot of memory and CPU. So what Docker will do is it will take the help of existing operating system, whichever was there, the operating system, and it will use for the app one or binaries one. So here what we'll do is Docker will have a capability to create different containers like this. This one container, this one container, and this one container in a single operating system on top of a VM. So this is the Docker architecture. So in general terms, let me quote an example. So for example, let me show you one more image. Mm, Mm, yeah. Okay. If you see here, this is the infrastructure architecture which we have. Uh, yeah. So this is the infrastructure architecture. So if you see here, this is the container engine, which is nothing but the Docker software which is installed. So for example, our infrastructure is AWS, which we are going to use in today's lab. So in AWS, we are going to take in one, say for example, AWS Linux operating system. So on top of that, we will be installing Dockers. So inside Docker, say for example, you want a separate one. Say for example, here you want Linux, here you want an Nginx based one, and you want different containers. Like this is container one, container two, and container three. So, but how many systems are you taking here? So you are taking single system. Um, so you are taking single system which will have this container, and in this single system you will be creating three different containers internally. So if you see here in this first diagram, so if you want to run three applications, see Docker is mainly used for your microservices based applications where you want to run your microservice applications in a different containers. Okay, so for example, this is your admin container, and this is your client container, and this is something like your operator container. So if you want to, if your application has a three modules which has multiple um, endpoints, so you want to separate it out logically, so then you want to run out into three different, you don't need to spin out three different virtual machines. Say for example, in this case here you want to take one AWS Linux machine, and here you want to take some Ubuntu Linux or some AWS Linux. Like this, if you see here, the cost of the hardware or the cost of the infrastructure will be more here. So that's the reason when you are going with the Dockers, you can take only one mission. This mission you can use with multiple containers. On the fly, we can create a containers using this Docker software and work with that. So are you clear the major differences between what is virtual machine and what is Dockers?
Yeah, Harish. So
Yeah.
basically, Docker is one machine, but you can have like multiple,
Containers.
see multiple containers, and then that can be utilized as multiple VMs, like different
Correct.
operating systems in one
Correct.
container.
Yeah.
Okay.
Yeah. And the main advantage of this one is you can create any container of you. You can create your own container. Say for example, till now what we have seen, we have launched AWS Linux mission, Ubuntu mission we have launched, and Windows mission we launched. So these are the three operating systems what we launched, right? Okay, today you want to launch one more operating system. So for example, if you download Ubuntu, it will be Ubuntu 16.04. If you go for the Ubuntu and download, it will be around 1.3 GB of download. When you extract this one, it will eat up the space around 2 GB space, correct? So this in a general term, almost at least minimum 2 GB of hard disk space you need, and you need some RAM requirement and CPU requirement to run this particular Linux, so Ubuntu based RPMs. But if you want to design your own container, say for example, your container should be very lightweight, which where you should not have ping operations, if config, then you have other operations like netstat, then netmask. Like this, all these unnecessary tools which are not required in this operating system, if you remove, on editors like nano editors, vi editors will come, right? So if you remove all these bullshit editors from this container, then your container space will be around, this 2 GB will become around 130 MB or 140 MB. So then you can make this as one container. So for example, this container is in on top of Linux, and you want only an Nginx server inside this. So you can create your own container, and you can make this as an image, and you can save this in registry. Okay. So let me give, okay, let's take the lab notes. Okay. So you need to understand what is the difference between registry and repository. So this is a very confusing one. So Docker has a portal called hub.dockers.com. So on repository is which is something similar to our GitHub repository or Bitbucket repository we have, right? Which is similar to that. And registry is a registry can store multiple repositories inside that one. So let me show you one example. So log into hub.docker.com. So you need to have your credentials registered with Dockers and log into this Dockers. Yeah. So if you see here, I have my repositories. These are my demo repositories. So I have one which is for demo batch Ninjix server, and Ninjix server which is created for 15th July. And I have a Tomcat based repository. So like this, so in this one, I have only the Ninjix image, and here I have the Ninjix image with some little modifications, whatever the web page which we get default, right? So I have changed those web page and saved as a image. Now I can download these images and I can run these images as containers in my own thing. So like this, whenever you create your own, say for example, you want an image for a testing team. Okay, so what your testing team should want? So your testing team should need Tomcat server and Java and developer source code like war file. So when you have these three, your application will be running. So if you want to run your automation scripts, what you want Selenium to be installed and your test scripts to be downloaded for this mission. So for this example, so I will create an image which will contain everything like this. Okay. Once everything is available, then I will push it to hub.dockers.com under my repository. Okay. This is a public repository where you can push your images and you can store your images here. Either it can be public or you can make this as a private also. So if you see here, so this is my own repository. So if I want to install this repository image, right? So I can just copy this command and I can use this in Docker system. Okay, in today's lab, what we will be doing is, so we will see how to install Dockers in VM mission. So here I'll take like AWS Linux. So after installing Docker, let us see how to start Docker service. How to uh, uh, let's say how to download or pull images just to images and execute containers in Dockers. Few commonly used commands to understand Docker's functionalities. So let's do Docker's commit to external repository. I'll tell external repo sub.dockers.com. So we will take some web server. We already know what is Ninjix web server, right? So let's install the same Ninjix web server and modify this one a little bit. Modify this server as one image. Okay. Then commit this image. So this is what we can see in Dockers to understand Dockers better. So once you understand this, once we've done all this one, you will get one idea. Okay, what is Docker? What all we can do in Docker? How to create images, how to run the containers, and how to modify the containers, how to log inside containers. I'll show log into containers also. Log into containers. Execute multiple containers with single image. Yeah. So we will see these concepts in Docker first. Then we will see what is ECR and what is ECS. So if you don't understand this concept, right, then I can directly go to the user interface and I can create some repositories and I can create some containers, task definitions, and execute the task. But if you don't understand the Docker concept, this is utterly waste. I mean, it'll be something like a user interface, which you like. It will be like a Bengali movie, which will be watching with a Hindi subtitles. Okay. Mm. Okay, now let us take one EC2 mission. See, here you can take, usually I prefer to take Ubuntu mission. So Ubuntu, sorry, Ubuntu 16.01 or 18.01. So for example, while selecting your VM, right? So for example, if you have selected 16.01, don't go and blindly install. You will have a command to install Docker flags like apt install dockers. Don't blindly install this command, because if you execute this one, it will pick up whatever is the latest version and it will install inside this Linux system. I mean Linux version system. You will have a lot of compatibility issues. So first go to your documentations here, docs.docker.com here. So here you click on download and install. So you can select for Docker for Linux. Mm, if you come down here, you have the platform, right? So for example, if you are installing for Amazon, right? So if you are installing Amazon, follow this command, CentOS. Or if you are installing Ubuntu, select Ubuntu. So let's click on Ubuntu here. So it will support only these versions. Now if you take any other VM, say for example, uh, yeah, 20.04, right? So if you go and install, 20.04 is also supported now. Earlier 20.04 was not supported. So any Ubuntu version which is of this operating version, then you can follow up these commands. So first install this command. If any already Docker is there, it will be removed. Then you can follow up this app get update and app get install, and you follow this documentation. Now since we are doing for AWS, right? For AWS also there is an issue. So if you go for on CentOS, right? So the by default, what will happen? AWS will have the own packages. So for example, like this AWS Linux extras install Docker. Linux, in this Linux extras, you will have Docker package by default. Some the softwares like Java, Ruby, Python, and those softwares will be as a part of the package itself. When you launch virtual machine, you will get them. So that you can see it here clearly. So if you see here, if you are selecting this one, right? So AWS supported image, this image will contain AWS command line tools, Python, Ruby, Perl, Java. This repository include Docker, PHP, MySQL. So I will select this image, so that I will get Docker by default. Just give me a sec. Yeah, sorry for that. So I'm selecting this one. Why? Because after creating the package, right, we will be pushing our own package, whatever we have created, to our ECR. ECR is nothing but Elastic Container Registry. Okay. So when you're pushing to ECR, you want AWS CLI command line tools. So to be installed. So if you take Ubuntu server, you will not have AWS CLI. You need to manually again follow some commands to install that one. So that's the reason I'm selecting this particular mission image. Okay. So questions here? Any questions till now?
It's okay as of now, Harish.
Yeah. So you can take your free tile. Free tile is should be fine for Dockers. And let me launch in subnet one.
So Harish, we have just picked an instance
Yeah.
wherein we have Docker pre-installed, right?
Yeah, it is pre-installed. We need to enable it. I will show you
Yeah,
how
yeah.
to enable it.
Okay.
Mm. Mm. Okay. So we have launched our mission. Uh, Okay, so how to install Dockers, right? So for example, if you want to install Dockers, so this since we already have image, so if you go and directly try this one, so check in this location whether already Dockers is there. If it is available, just remove this one. So I don't have any Dockers repo here. So what I'll do is I'll just try installing this command. This should give an error. Okay. So this is the command which is used to install this extras. So already loaded. And this is the command which is used to install Dockers. Okay, so it is complete. Now if you type Dockers, okay, just type Docker version, sorry, Docker. So you can see all the Docker options here. So what are the Docker commands? What you can use? You can see the options. Like you have a service here, stack, swarm. Swarm is something like similar to Kubernetes. And you have some commit command, build command. So these are the commands which we will be using for Dockers. Okay. So we will see few of these commands here today. So let me clear this one. So you can check the version of Docker, what version it is installed. So it is 19.03.6. CE means community edition. Okay. Okay, now we want to see image, right? Say for example, if we have seen here the container, right? So if you want to run this container, say for example, this is your container 1 and this is your container 2 and this is your container 3. In order to run this container, you need image. So image will contain the definition what exactly this container will have. So if you go here, um, if you type Docker images, it will show a list of images. So okay, let us check whether the service Docker is running or not. Service Docker status. So Docker is stopped. So let us execute this one. Okay. Check the status. Okay, Docker process ID is running now. Now, if you go and check Docker images, so you don't have any images or don't have any repositories which are there in this particular system, right? Now, say for example, if you want to install, say for example, the Linux, sorry, the Ninja server image. So what we can do is, let's go to hubdocker.com. Here you can click on explore. So it will show you the list of the softwares which are available. I mean list of the images here. So you have for CentOS, you have for Python, for Java you have, for Rabbit message queues you have, Go language you have. So Docker registry also you have. So Ninja server. So we want this server. So select that image. So this is the command to pull the image. Again, it'll be applicable same here. If you directly copy paste this command and execute, it will default install the version which is latest here. Suppose if you want a dedicated Ninja server version, say for example like 1.19.2, then let me copy this command. So this is your command, right? So then you need to give 1.19.2. 19.2, right? Yeah. So if you execute like this, it will try to pull that particular Ninja server version. So otherwise, you can give latest also. If you give the tag latest, it will pull whatever the version whichever is available latest. So for example, if you see here, now the image is downloaded. You can type Docker images. It will show the Ninja server image. The version is 1.19.2 and image ID is this one. Every image will have a unique ID to identify. It might be a name or it might be an image ID. So whenever you don't give any name, what will happen is Docker itself will give a name for that image. How the name will be look like is like it might be any human emotion dot any scientist name. That's what it will give. Say for example, angry, and here any scientist name like APJ Kalam. Like that, it will create one image name. I will show you that. Okay, now let's say, for example, if you want to download the latest Ninja server version, so let me give here as latest. Docker images. So if you see here, now we have two images. We have Ninja's latest version and we have Ninja's 1.192 version. Okay, now we want to run say three different containers. This container one, container. Okay, let me draw in paint so that we can refer that. Okay, so let's assume this is our EC2. So inside this EC2, we need a container. And container 2 and container 3. So this is index 1. Index 2. Index 3. So this is our EC2 mission. Okay. So whenever you external internet will connect, right? So we know that every EC2 will have some network interface, correct? Do you remember this network interface? ETH0. So this is our network interface. Okay, now you need to run, this is a single VM. Inside this single VM, you want to run 3 different containers. This container 1 and this container 2 and this container 3. So for the external internet, so for example, this external internet, so whenever the people will run, they don't know that there are 3 different containers here. For them, it is 3 different applications. So for example, this is let's say this is movie application, and this is audio application, and this is a subscriber application. So for them it is 3 different applications. Now what Dockers will do is, let me put, yeah. So whenever an user he will come to Ethernet cable, I mean, so whenever an external internet traffic will come through Ethernet 0, so what we will do here is we will map with the default port like this. For example, 8000. In which port we are running in Ninjax here? 80 port, right? So you will give 80 port here. Here also you will give 80 port, and here also you will give 80 port. But if any external traffic which is coming, we need to map for different servers, right? So for that, what we'll do, we'll take some list of ports which are available in this EC2 machine, and we will map this internal port to this Ninjax server. So for example, 8000 will map to 80, 8001 will map to 80, 8002 will map to 80. Means for this we are mapping 8000, and for this we are mapping 8001, and for this we are mapping 8002. Like this, say for example, if any user who is related to Ninjax server 1, if he is coming, since this 8000 port is already mapped to port 80 of this container, the traffic will be sent like this. And say any user who is coming with this one 80, he'll be mapped to this one. And any user who is coming with 802 port mapped, right, he'll be transferred to this container. So this configuration will be done in while starting the containers using the port number. So that we will see here. So this is what we are going to do. We are going to run 3 containers. One is same Ninjax server, but with 3 different containers, right? So we will map 8000 port to one server 1, 8001 port to server 2, 8000 port to server 3. And we will see whether when we hit this from external, whether that particular server is calling or not. So after that, what we will do is we will modify some web page here inside this Ninjax server. We will make this as our own image. Okay. Earlier, this is a Ninjax image which we downloaded from internet, right? Later, we will rename this image as August 1st batch image and push back to our hub.dockers.com, so that whenever I take this latest image and install, whatever the changes we have done inside this Ninjax will be available for the end user. That's the agenda, so that you will understand how exactly Docker is. Later, the same concepts will be repeated in ECR and ECS. Clear? Okay. So if you go to our Linux machine, so we have our images here, right? Now, how to run this image? Say, for example, you want to run the latest Ninja server image. So you can use the command to pull this image. You use Docker pull, and you have given the particular image name. Now, in order to run this image, you need to use Docker run -it. Then you need to give the repository name like nginx latest. So if you see here now, you are inside a container. It started a container. Now the container is running. So if you want to check how many containers are running in this particular VM, so now inside I'm container, right? If I press Control C, the container will shut down. So let me duplicate this session.
So Harish, I mean, if you want to run multiple containers, you have to run it via multiple sessions, or
No.
or
There
you
is a
can
way.
run it via background command.
Yeah, background command is there. I'll show you before that.
Okay.
So Docker PS. So if you type, it will show you what exactly is executing. So this is the image ID which is getting Ninja's latest is executing, which is started 50 seconds ago, right? So for example, if I come back like this and check the status here, Docker PS. Now you cannot see any containers, right? Why? Because we have come out of that container. We have shut down. Control C will shut down, execute that command, right? So if you want to see what are the containers that have previously executed, just provide -a so that it will show the old container and the history of that one. So created 1 minute ago, and so status also it should show exited. You can see the status here. If it is running, it will show running. Otherwise, if it is already exited, it will show exited. And you can see the name here, Hungry, and this Liskov is maybe some scientist. You can search his name. Yeah, he is some design pattern scientist. He is a guy. Okay, so let us clear this one and go back to our Docker images. Okay, now we want to run 3 containers, right? So, but we want to run using this one only. So what you can do is Docker run. So you can append D. D means it will detach once the container is started. It will detach you. And okay, let us put one more command here. This is like rm. Shit. Docker run. See, RM means after you shut down the Docker, right? It will automatically remove that particular container. Otherwise, you need to manually go and do this one. So I'm just right now while creating the container itself, I'm providing the RM tag so that the cleaning will happen automatically when we shut this container. Okay, and DIT means we are detaching this one. So IT means we will log in. If you provide just IT, you log in inside the container and you will still have the access for that container. So DIT means after you execute this container, you will detach and you will be still in this particular our Linux machine, which is launched in subnet 1, right? So DIT you provide, and you can give the host name. So let us give the host name as Ninjax1, and you can give the command like name also. So this name is the name of a container, and host name is the host of the container. I mean, you are starting a new mission, right? For that mission name, you are providing this one. nginx. Make sure. And what exactly we need to start, right? Where is the image name? Ninjax latest. So before that, let us give the port number also. We need to map 8000 port to 80 port. So this 8000 port is a port of our current mission, which we launched from EC2, right? Our EC2 port 8000. We are default Ninjax will run on 80 port, so we are mapping to that particular 80 port. So then Ninjax latest. So this is the image which we are going to run as a container one. So I just gave container one name is as Ninjax1, and so we are detaching it after execution. So any queries here in this command, I'll copy this and put in lab notes.
Harish, so this will kind of run the command in the background, right? Or we can use the ampersand sign as well to run the command in the background the way we do it in Unix.
I'm not aware of that, Sailesh. So this is the way for Dockers you need to execute the command.
Oh, okay, sure.
You just executed another command just
No,
before
I
this.
didn't execute. I just copied one. So
when no, before this one, when you tried, taking that.
Yeah, run 90.
Page.
This one. Sorry, this one.
Correct.
Yeah, so yeah. I executed, yes, the Docker container has been already started, but when I pressed Control C, right, it automatically terminated the container instance and came out of that one. So, so when you do Docker images, Docker PS, we couldn't see any running instances, right? That's why, because we are out of this container box. So
yeah, that's why we are doing.
Yeah, that's why we are doing this command. Okay, so let me execute this one. So Docker error response conflict. Why? Because Ninjax server 1 is already executed. When executed, you saw, right, a unique name has been displayed. So you can check Docker PS. So this container is already started executing on port 80, which is mapped to port 8000. So if you go to our EC2, take this one and just give 8000 port. What now it will do is it will directly take the request from external. We are giving a request. It will take the request. Since 8000 is mapped to Ninjax one container, it will go and open this Ninjax one container here. So execute this one. So you can see the welcome page of Ninjax server, right? So let us run for Ninjax 2 and 3 containers as well. Same command. I'll just change the port number and the name of the container.
But we have only got two Ninjax. But we only probably installed two Ninjax server, right? Initially, latest. I mean, two versions. I mean. So you installed latest, and there was another one, 1 point something, isn't it?
Yeah, I will explain you the difference. So if you see here, these are images. Okay, image is nothing but a replica. So for example, in our EC2, when we take backup, what we have done, we have taken the created image for this EC2 and we have kept here. So that whenever you are going to create new AMI, if you take this AMI, inside this AMI, whatever the servers like Ninjax or Tomcat or user data will be there in our new system. Same concept applies here as well. So we have this as one of the image. Okay, the same, using the same image you can run multiple containers, but if you are using this latest one, in all the containers Ninjax latest server will be installed. So this is this is a skeleton. Using the skeleton you are running the container
and number of
okay.
Got it.
So currently we have executed two containers, right? So you can see here, two containers are running. This is the one and this is the second one. And you can see there is no name coming, right? Like you need to have a emotion name plus the other one. So why? Because we have provided host name here, right? This is the host name. So it is renamed. It came as Ninjax1 and Ninjax2. Okay. Now let us run the third one also. For this, I'll change the port as 8002. Okay, so we got this one, and if you see Dockers PS, so now you can see all the three containers are running here. Fine. So now if you go external here, so copy the same URL and give 801, and you can give here as 802. Clear? So in now these are three different containers, but you might ask what is the guarantee that so these are three different. So let us change some text in all the three so that there will be some differentiation. So to change this text, you need to log into so Docker PS. So currently you are in where? You are in EC2 mission under root user, right? So if you want to log into the server mission, I mean the container which is there on Linux, say for Ninjax1. So this is the container you want to log in. So after logging into this container, then you want to change this one. So before that, what I'll do, I'll show you the size of the image. So Docker images. So if you see, the size is 133 MB. So why this much less means, I'll show you the exact reason for that. So how to log in means Docker execute it Ninjax1, yeah, and let me put as bash. So if you see here, now from EC2 mission, I have been changed to Ninjax mission, I mean Ninjax container. Now I'm inside the container. So let me clear here. Yeah. So if I do ifconfig, so what this command should return? This should return what is the IP address and other things of this particular mission. So there is no command. So if I type ping command, no command. So like this netstat, no. Why? Because they removed all the unnecessary things and they made this as a very lightweight image. Okay, so if I want to do some editor, I press touch. Okay, touch is there and say nano abcd. So nano command is not there. So but if you want to edit this HTML page, we need some editor, right? So let us install nano here. So apt update. Okay, apt get install. Sorry, install, I guess. Install no. Yeah. So nano editor is installed here. So nano user share Ninjax inside this HTML folder, inside this index.html. Okay. So this is the web page what we are seeing. So let me rename here. This is custom container one in AWS VM. Okay, and Let me remove other things. Yeah. So only this h1 tag should be available for server one. Okay, and all this other content I removed. Okay, let me save this and execute. So you can, if you want to come out of this one, right, don't press Control C. If you press Control C, the container instance will be lost. So just type Control PQ so that you will escape the sequence and still the container will be running. If you want, you can check with Docker PS. So if you see, the Ninja server container is still running. Now if you come and check here and refresh this page, you have only one line which we have modified. Clear? So now you know how to log inside. Say for example, you have spinned up 3 containers. So you know how to log into inside container and change the files which are required. So for example, this container one, you logged in here. Here there is an inject software with HTML page. But in order to modify that HTML page, you don't have any editor. So you install Nano Editor. Using this Nano Editor, we typed the HTML, modified the HTML page, and we have exited out of this container. When we refresh, we will see the latest changes which are updated here. Clear here? Any queries?
No, Harish.
And okay, so let us do it for the same like for the other container. If you see here, now we are logged in as Ninja2 container and apt update.
Will this command be similar for Mac, Harish, or it might be like different?
Yeah, commands in Mac is all same, Namita. See,
Okay.
but for Mac, the Docker, you will get a DMG file. So you can, through user interface, you can work, Namita. Either you can work with a terminal or you can work with user interface. Terminal commands are same like Docker. Sure. All the commands what we are using, it will be same. Otherwise, you will have a good user interface. From user interface, you can select what is the container and you can push to that cloud and you can update from cloud. Everything can be done.
Sure. Thanks.
Yeah. Nano user share index.
Harish, is there another way of finding the path?
Path, Ryan.
Yeah.
See,
Using a list, by using
Ninja
an LS and
LS, yeah. See, I am familiar where the installation will go, right, for Ninja. Default installation path is this one. So, and this is. I'll use this test as it is, and let's save this one. And if you refresh this one, the system2, it should load system2 server, right? So the container 2 is loaded. Let's leave container 3 as it is with the default one. Okay. So now you know how to download an image. Taking a Linux machine. So after taking the Linux machine, you have installed the Dockers. Step 2 is done. So starting the Docker service, how to pull the images to Docker and execute the containers in Dockers. Are you clear with this, right? So how we have pulled this one? So Docker pull Ninja server and whatever the version we have provided, that version we have given here. So you can see what are the images available in this particular using the Docker image command. Okay, so after this one, we also seen, so just give me a second. Yeah, so we also seen a few comments how to check the Docker containers running or not, and how to start the run the Docker commands, and Docker commit to external repo. Yeah, so now we will see. We had taken the Ninjax server, right? In Ninjax server, in this image, Nano was not there. We installed Nano and we modified some HTML page, right? So now if you want to make this as an image, make the total one as our own image. Let us name this image as August 1st batch. Okay. So if you want to do this one, how can we do that? Using this Docker command, let's see. Go to this mission. So clear this one. Yeah, this Zoom is becoming Docker images. So now we want to make this latest one into a customized image one, right? So what we can do is Docker commit, and we need to give the, okay, so before that we want the in image container ID. So what we can do, Docker PS. So this will list the containers. So we want to take any, say for example, we want to make this as one our container. This one as our container, so that whenever next time we launch this container, by default when we start, our page should be this one. So for that, this is the container ID. So command is docker commit, give the container ID, and here you actually you need to, okay, it should come here once we commit. So that what I'll do, before that I'll do docker login. So it will ask the username and password for this hub.docker.com. So provide your username. Docker login. Okay, login is succeed. Now what I can do is docker commit and give the container which you want to take. So we will take the.
There's a typo, Harish, in Docker.
Yeah. Docker commit, and this is the container ID. And you need to give the location. So this is my repository name, hapmma/, and here I guess we need to give the name of the like this, I guess, Ninjax latest. Yeah. So once you commit, then you need to tag this one. So tag is also the same. So instead of commit, okay, so you need to give the clear. So you must see our committed image here. Okay. So this is our custom image which we have committed. So in order to tag this image, Docker tag, give the image repository name here. This local repository name, and in server you need to give this is my server repository name, and inside that repository, if you see here, now currently I have only 3 repositories. The 4th one we are going to push it here. So it is like, let's say August 1st. Nginx. So once you tag this one, then you can check Docker images. Okay, so it is there. So push this image, Docker push. Yeah, so this will be pushed to this particular location. So docker.io. So if you come and check it here. Let me load from here. If you see here, August 1st Nginx server is pushed few seconds ago. Okay. So now you also seen how to commit and push the image and our custom image to dockersub.com. So using this custom image, now whenever you want to execute your the spin up your microservices, you can just bring this image and execute this image. Usually how this Docker is used is, in the test environment, they will install all the prerequisite softwares, and so usually you will have a Docker configuration file. Docker configuration will be maintained in JSON and YAML, which is similar to our cloud formation where we have seen. So all the things will be maintained here. The custom image will be there, and later from where you need to download the source code, what Java version you need to install, what Python version, that and all will be declared, and what web server you want to install will be declared in this JSON file. Once the images are there in a container, so the same image will be pushed to UAT, and from UAT will be pushing to production, so that the replica of the container will be same across all the things using the configuration. Okay, so yeah, this is in a nutshell about Docker. See, Dockers I have not explained completely in detail. So we need around 7 to 8 hours in order to explain this Dockers in programmatic way. So creating your own JSONs and YAML files. So, but for now, if you have understood this lab, whatever we have done till now, you are going to understand what are ECR and what are ECS, which you are going to do in next half an hour. Okay, any queries here in the Dockers?
That's okay, Harish.
Yeah.
So Harish, is ECR and ECS, are we able to finish in half an hour?
Yeah, you can.
Because if it is going to take longer, then that's my opinion. If we can take it another day, otherwise.
No, I cannot extend the sessions, Sailesh. If you have some work, you can refer to the recording class. I want to wind up today. That's what see in these sessions which are related more into AWS, which are not related to some containers or Docker's classes. But since I have included in syllabus, I am just giving a overview of ECR and ECS. Okay.
Okay.
Yeah.
Sure.
So detailed sessions we can discuss in GitOps class. So in GitOps we will have around 4 hours only for Docker Swan and Kubernetes. So if you don't understand what is Dockers and Docker Swan, then you will not understand EKS. EKS is a service which is running for Kubernetes. So for that you need to understand Docker Swan as well. So all those in-depth concepts I'm not giving. So this is in detail, like what is the introduction to Docker and other things. Okay, now we have seen in a plain, what is a plain Docker, right? So how to create a Docker, install a Docker in a VM, and create a download image from public repository and run the containers. From the containers, we have created our own image, push our own image to our public repository. Now, if you see here, AWS is providing two services. One is your ECR, image container registry, elastic container registry, and ECS, which is elastic container service. First, let us see what is elastic container registry. So if you see here, initially I told you need to know the difference between registry and repository, right? Repository is nothing like you will have multiple repositories under one registry. Registry is nothing but your ECR, okay? Your ECR in public, this is the Dockers one. hub.dockers.com is called as your ECR, Okay, AWS is providing internal, I mean, you can store your own repository inside AWS under ECR. ECR is the category. So in external, if you are not using public cloud, if you are using your own infrastructure or other things, you will be relying on hub.dockers.com. Okay. So now here you know how to create a repository, right, in the public. So come here, you can create a repository, or you can directly push the repository from the Linux machine using Docker login and Docker commit, Docker tag, and Docker push. So we have seen those commands, right? But how exactly you can do the same, the same image or custom image to ECR, right? So for that, create a repository first initially. So let us give the repository name as August 1st and create. Okay, now you have your own repository name. So go inside the repository. And if you see what are the push commands. So here, what commands we have followed. Here, if you see here, Docker commit, and we have taken the container ID and we have given the name for that one, and we have used the commit initially. Then we have used tag. Okay, so this tag will attach the image to your this one, and once you push push command, it will push to your public hub repository, right? Now you already have image here. If you see, if you type Docker images, you already have this image. Now you need to push this image to your ECR, means your elastic container registries. So you can see the what are the push commands you need to follow for this one. For this, you need to have a IAM role, which is to be configured in this Linux server. Okay, so because you need to authenticate, right? So anyone can push to this ECR if they know this ECR container name. So let us create an IAM role. Okay. Go to the users, create new user. Let us give as August 1st ECS. Okay. So if you see under permissions, so you attach the administrator policies, administrator access, and ECS full access, and ECS task execution policy, and deploy a role for ECS. By this, it should this both should be also inherited, and also provide CloudWatch logs also. CloudWatch name, and we'll give as ECS. So we have seen, right, how to configure this programmatic access in AWS. While doing endpoints, we have seen, and while doing S3 bucket, we have seen. Okay. So the secret key will be shown only once, right? If you go to a Linux machine, AWS configure. It will ask initially for your access key. So copy your access key, and it will give you a secret key, and it will ask for the location US East 2, and I want in table format. Okay, so now we have configured this particular user in this AWS configure. Now let us see these commands. Go to your ECR, push commands. So before this one, you need to do registry authentication. Now this whole documentation, I guess, it's not updated. So you need to use this command for that. Not this one. Yeah. So execute this command in your Okay, so now you can execute your push commands. Okay, you have successfully logged in now into your ECR. So this two you already done. You have created image and your image is ready. Now you need to push this image to your ECR. So directly take the push command. In this push command, what exactly you need to modify? So you need to modify the container, this one. So August 1st latest is not our image name, that is different. So what I'll do is I'll copy that here. Docker, yes. So I want to copy this. Okay, when you execute this one, so tag is done. So now we just need to do push. Docker push command is directly here. You can take. So now if you see here, the code is getting pushed to our ECR. Okay, so it is successfully pushed. And where you can see that is close this one and refresh this tab. Okay, this is your image URI. So now if you want to use this image, right, or custom image, so you can copy this this one and you can provide to use your image here. So now simple. So initially what we have done, so in our plain Dockers before coming to EC2, we had our custom image, which is this one. So we pushed this image into our hub.dockers.com. So in AWS, ECR is nothing but replica, I mean, similar to dockers.com, but it is into AWS. So we want to push this one. So in order to do that, we want AWS configure to be in this mission. Once the AWS configure is done with the IAM role, then we started executing, we logged into ECR using the push commands. Then we have tagged this particular image name and we have pushed using these commands. So are you clear? Any queries here?
No worries.
Yeah. So ECR it's nothing but a hub.dockers.com. So if you know very good about Dockers, right, then this will be pretty clear for you. Now let us see what is ECS. So ECS is like Elastic Container Services. So here what you will do is, so this is a 2 minutes video is there. Just go through that. I don't want to waste time now by showing this. So when you launch for the first time, just go through this video. Then in a nutshell, you will understand why Elastic Container Services are used. Now, what we have done from the beginning of the lab, so what we have taken a plain Linux machine. In Linux machine, we have installed Dockers. So we have downloaded images. So after downloading images, then can you hear me, guys?
Yep.
Yeah. Okay. So after downloading the image, so you can you created your own custom image, then you have pushed this one. So all these are manual steps, right? So what ECS will do is, so if you can give the reference of ECR, so from ECR directly all this execution will be happening. It'll only take the EC2 mission. It will spin up one or two more EC2. You can create clusters if you have a requirement. So you can create multiple EC2 missions. Then you can give a task definition. So the task definition will be executed and the tasks, all the containers will be executed directly if you push your container image code inside this ECR. Now let us see how this ECR can be configured. Okay. So go to your clusters here under ECS. So create a cluster. So select EC2 Linux. I'm selecting Linux machine. You can select Windows also. So let's give August 1st, ECS. I see you can select spot instances also so that your cost for your EC2 instances can be reduced. Right now, I'll leave it to on demand. Here I'll select T2 micro. T2 micro, and I can run 2-3 EC2 servers also. I'll run only one for now, and I'll select AWS one only, and root volume I'll give, and key pair I'll give is August 1st key pair, so that we will log into this. See, there is no necessity for us to log in. Whatever the tasks we push and execute, those tasks will be running, and we can check it the outputs in CloudWatch only. But I want to show you people, right? So this is the manual thing what we have done till now, but how exactly ECS is doing all those things in background. So that's why I'll give this key pair, and VPC I'll select August 1st VPC, and I'll select all the subnets, and I'll enable public IP address, and security group I'll give August 1st, and create cluster. So let the cluster be created. So meanwhile, so what we'll do is I will show you how exactly the code will look like. AWS Ninjas task definition. Okay. So after creating this cluster, right, you need to create task definitions. So this task definitions will be documents. Let me open this GitHub. I guess I should have one. Ninja server, right? So this is your example task definition. So let me put this in Notepad. Okay. So if you see here, image name is Ninjex latest. If you give Ninjex latest, it will directly down. See, ECS will run your images directly from Hub Dockers repo also. It can take and run. It's not like only it will take from ECR. Suppose if you want to give only ECR image one, then you need to give this one here. Okay, this got created, right? So let's go to ECR. So this August 1st repository name, right? So this is the image URI. So copy this URI and you just replace this Linux latest with this image URI. Okay. And if you run this one, initially it will fail. Why? Because we need to create this log group. And log region, let it be like this. Okay. Okay, so the cluster is created. Let's go to view cluster. So if you see the cluster, you have only one instance running. So here you have multiple options, right? So capacity providers means suppose you can configure this for auto scaling group. So say for example, whenever your container size is increasing, say for example, you have a web application which will run in a stable, which requires say for example 2 EC2 machines. All of a sudden, if a user is using one functionality like image processing, so then you need additional 2 EC2 images. So if you don't select auto scaling group, right, there are chances that these containers might go down, right? So that's the reason they have provided the option for auto scaling groups. So as I told, right, that listen to the 2 minutes video, you'll understand what exactly ECS business use case is. And the tags are normal tags. Scheduled tasks, you can task particular schedules to run on the containers or tasks. Metrics, you can, these metrics will be pushed directly to CloudWatch logs, or you can view here. ECS instances are nothing but your EC2 instances. So if you see here, so when you run this container, right? With the cluster, we have selected one instance to run. And if you click here, it will take you to EC2 console under instances. Automatically, one EC2 instance will be spinned up. And this inside this EC2 instance, if you log in, Dockers will be installed and kept ready. Okay. So let's log into this later after once we install tasks and we run tasks. Okay, where is it? Let me close few tabs. Yeah. So then we have tasks. So before coming to task, right, you need to understand what exactly this task will do. So task is nothing but if you need to provide a task definition for this task. So for example, if you click on run task, here you need to select forget or EC2. So then if you see here, you need to provide what is the task definition for this one. So let me show you how to create task definitions. So you have option here, click on task definition and create a new task definition. So let me select EC2 here. So either you can give manually here, like giving what name you want to do, what task you want to do, all those. Or as I showed you here, right, the container image code. Go to JSON file. So copy this one, add container. Sorry. Configure via JSON. Okay. So replace this default code with your own custom code. Okay. Then when you click on save button, automatically all these options will be loaded here. Okay. So if you see here, the name is like default name is like Ninjax, right? So you can give your own name here. August first match. Okay, let us create a task definition. So task definition is successfully created, which is nothing but this one. Okay, and I guess I have created this log group. Let us confirm. Go to CloudWatch. Log groups. Yeah, so this is our log group, which is already there. Okay. So log groups is there. Fine, you will not get any errors. So for you initially the log group will be not there. So just copy paste this one and create a new log group with this particular name. Okay. Okay. So next step is, so okay, task definition we have created. Come back to your cluster. So go to your August 1st cluster. And if you go to task, right, now you create a task and you can run a task. So creating a task and running a task is nothing but running your containers. So let us show here. So select EC2 and this is our task, right? Ninjax August 1st group. And see, if you remember launch configuration for auto scaling group, so similar to that, task definition will allow you to store multiple revisions. Say for example, in first revision, we don't have a nano editor. Second revision, you have a nano editor. Like that, you can store multiple revisions here. And cluster is, we have August 1st ECS. And how many instances we want to run. So let us run these 3 instances only. I'll give 1, 2, 3. Okay. Task group I'll give as August 1st web servers. And other details I'll leave as it is, and the advanced details and all as it is, task override and all. When I click on run task, right, so you can see the tasks are getting running here. So this is the task definition, Ninjax August 1st, first one, second and third. And if you see the container, you will get a container ID. Okay, and if you go, just let me refresh. So if you see here, all the tasks are running. Suppose if you don't see immediately, as soon as you run the task, if you don't see any columns here, just click on this one, stopped. Here it will be showing, because if any errors are there, the task would be stopped. For us, since I already created the log group here, so I didn't get any error. And these are the other things. Okay, so simple configurations. So now the tasks are completely running and executing here. Okay, so you can check every task. Say for example, what happened to this initial task, right? Click on this one and it will be open here. You can check the task is running and which EC2 instance the task is running and container instance. And you can also check the, yeah. So this is the external IP address, and this is the port which is mapped. We have mapped 8000 port, right? But here ECS will automatically map 32,770 port here. So if you see here, this is our custom what is that image, right, which we have pushed to ECR. If that custom image is pushed in and executed here. So for other two also, since we have installed the same custom, you can check, go to the tasks here, go to second task, and if you check the external link, from the same image it is executed. So like this, if you see here, the port number is 32770, and if you see here 32768. So the other one should be, since it is giving series, it should be 769. Let's check that as well. Yeah, it is really hard. If you don't know anything about Dockers, in 1 hour or 2 hours, you cannot learn these concepts. So if you see here, okay, let me move this one. 769, 768, 768 and 770. So these three ports are internally mapped to your Ninjix servers. Clear?
So Harish, because we have just used one image, it is displaying the same.
Correct, Namita. Okay. So because whatever the base image which we took, in the base image we have, this is the one,
this
right?
was the customized one,
yeah. So now what is running? So you have just updated one definition and executed. Yeah, you are able to see in the UI all the three tasks are running. How exactly this is running in the background, right? That's $1 million question. So if you go to your EC2 instance here, you will see an automatic instance will be created by ECS when we create a cluster, right? So this is the automatic instance. Now log into this machine. Close this one. So if I do Docker PS, right, how many containers you should be running here?
One. Sorry, 3.
Yeah, 3, because 3 tasks we have running. So every task is a container here. So if you check here, so this the first time we are logging. If you do Docker -version, Docker will be by default it be installed. Why? Because this is ECS managed EC2 instance to run the Dockers, right? So they will only install Dockers, they will only push the commands, they will only do everything for us. What you are doing is from the user interface, you are just trying to control the Docker from UI. So if you see Docker PS, let me change the settings. So if you see here, 3 containers are running here. Container 1, 2, and 3. If you see the time, right, all the 3 containers are launched in parallel. So, but whenever we are trying to launch here from our mission, right? So this is our manual Docker's mission which we set up. So if you see here, one is 44 minutes, one is 45 minutes, one is 48 minutes. Why? Because for us to type that commands and execute, it took some time.
Took some time.
But whereas Dockers will execute in parallel. Okay. All these three are fine. We know what are these three because these are three servers which are mapped. For us, we gave our custom port number, but ECS will automatically pick one random port number and map to that particular application port ID. All this is good, well and fine. So what is the fourth one? So there is a fourth one called agent, right? ECS agent. What is the job of this agent is, whatever you are giving in the user interface, the agent will execute all those commands and all those tasks from the UI. Say for example, this is your tasks. When you say run tasks, all the tasks will be composed. This ECS will be taking those requests through the API and composed it as a commands and execute those commands inside this one and do the automation for us. That is what exactly this agent is sitting here and agent will do. So to explain that, let me take. Okay, so your ECS is sitting here, and when you run a container 1 and container 2, and you are running a container 3, okay. Okay, so container 3, okay, right? So select your all these three containers are launched by ECS. Now what exactly is happening is, so in every container there will be an agent sitting here. So for example, one agent will be sitting here. So that is the agent here. So which is nothing but your ECS, sorry, your ECS agent. This is the fourth one. Okay, if you want to log into inside this ECS manage containers, right? Same command like docker execute it select container ID, so bash, right? So you have logged in as a container. Now let me change the. We already have Nano editor, right? Let us check if Nano editor is there or not. Request file. Yeah, Nano is there. So Nano user share Ninja, right? Okay, so this is our page, right? So let me change this as server. I don't know this one. Let's keep a server one only. Container one in this is not in AWS VM. This is in ECS. ECS AWS. Okay. Let us save this one. So if you refresh this links, right? This is not the one. Yeah. So this is a container. So in this container, we are able to see the changes what we have done. So ECS in a nutshell, it will do, it will install the job, it will do the job whatever we are doing manually. Everything you can configure from automation, I mean from the user interface. This will be in turn made as a commands, API commands, and your AWS ECS agent, which is sitting in a managed EC2, it will execute all those commands and it will showcase to you. Okay, and it will do the job. So there are other options. EKS, I'm not going to tell because you need to have a knowledge of how Docker Swan or Kubernetes will work. Then only you'll understand this EKS. So then you have services, right? So why these services is used, right? So for example, someone will shut down the task. Someone will come through user interface. So he'll select all the tasks and he'll stop the tasks. So that time your application will go down, right? Or say for example, your application, there is some failures, the application is getting stopped. So what your services will do is, like it's like multi-agent, right? It will run in a different zones. So for example, create service. So here you can provide number of tasks, right? So if you give 3, the same cluster will be run in 3 replicas. Okay, one replica is getting failed, the another replica will be executing. Okay, and also what exactly? Okay, any
Harish, what
question?
is that forget, by the way?
Yeah, forget, I'll tell you. Before forget, any questions here?
There is a memory and CPU parameters in the task definition which we
Yeah,
uploaded, right? So
yeah,
that is a container specific
yeah,
one.
container specific one when it will be created.
So what if happens if we give more
See,
memory in the
there are
definition?
two ways you can create a cluster. One is either you can come to clusters here and create a cluster from here, right? So right click and create a cluster from here. The other way is, so when you directly come to ECS, um, there is one more option. You okay, let me select this. Yeah, so here select the EC2. So it should show you this one. Say for example, this is your container. On top of container, this is your task definition. On top of task definition, this is your service. On top of service, this is your major EC2 one, which is running. So that is the architecture one. So first time when you're doing that one, so if you start creating cluster from this option, you will get that. For now, let me show you. Yeah. So to answer your question, under EC2, if you go here and here you can select task definition, task role, VPC model, task executions. Here when you're adding container, right? Click on add container. So here you can provide your memory limits on your port mappings or your advanced configurations, right? So if you're creating multiple containers, first create one container, later again you'll have the same option, add container. For the second container, what memory you want to give and what CPU you want to give, here you can configure. But for now, so we have not created anything in specific. We have taken a blank container code here, okay? So here we have not given any other parameters. So you can we just specified empty volumes. Network mode is bridge type, which we selected. If you see here, this is a, okay. So here we will have network mode bridge type, right? So we have selected bridge type. So on placement constraints we have not given. Family we just gave as a family name, simple family name. So here you will have multiple options to give. So for example, you want to run multiple containers. So you can give your container memory like this one, memory and CPU ones. So memory will be in MBs and CPU one will be, it will be like in parts ones. So there are this, we need to read the AWS documentation to configure. Yeah. Any other questions in ECS? Forget, I need to explain. I will tell before that. Are you clear how to create a ECR registry, and from the registry how to give the image reference for your task definition? So first thing is you need to create a cluster. When you're creating cluster, you will have two options. One option is either you can go with ECS or you can go with forget one. So the major difference between ECS and forget one is till now we have only deployed servers and we have seen how to scale the servers, right? So for example, we have only one container instance. So we have auto scaling group options here. Capacity providers. Here you can provide your auto scaling groups. So this and all is manually you are doing. I already gave you an use case, right? So for example, your web application which requires 2 EC2 servers when there is a normal user load. But when there are some few functionalities like image processing and all, that time you need additional 2 EC2 missions. If you don't configure these auto scaling groups properly, then what happens based on the traffic load which is entering into your ECS containers. So when everyone will try to use this image processing functionalities, this will go down, right? That's the reason you need to configure this section. Okay, so if you use Fargate, all this job will be automated in Fargate. So the only thing you need to do in Fargate is select particular configuration. So whenever based on the usage of the traffic, it will spin up additional resources how many it want, or it will remove the missions how it want based on the container usage. And also you should be a bit careful when you are configuring the Fargate, because a lot of EC2 instances it will spin up, okay, based on the configuration what you give. Then obviously what will happen, you will be charged for all these EC2 instances. See, charging for ECS is there is no charge. AWS will give this for free, but they will charge you for EC2 missions. In background, what will happen? We are spinning the EC2 mission and we are working with that, right? So for these EC2 missions, they will charge you. They are not going to charge you for some ECS agents or other things. Okay. The only advantage is here we no need to deploy ECS containers and other things. Fargate is a fully automated ones. Okay, questions? Any questions?
So Harish, this ECS, how that is related to target group, in the sense, if you configure auto scaling groups, then automatically this that will be related, right?
Correct. See,
Target groups and all.
see, auto scaling groups, what they will do, auto scaling groups, they will not understand what are EC2s, right? Auto scaling groups will know only what are target groups. So inside target groups, you need to keep EC2 missions. So you will keep all the target group, configure all the target groups here, and these target groups will be mapped to auto scaling groups. So whenever this target group need a EC2 missions or other things, then auto scaling here you will keep metrics, right? The metric thresholds. Based on the metric thresholds, these target groups, they will add additional EC2s or they'll remove additional EC2 missions. That's what happens. If you practiced, let me check if you have any image.
Yeah, I have got the answer.
Yeah.
I understand. Okay. But when the question comes to ECS and this auto scaling together, right, then there is a little bit bouncing.
Yeah.
So I need to practice, I think.
Yeah, see, it all depends on practice. How much you practice, that much you learn. But one thing, if you want to be perfect in ECS, you must know end to end how the Docker foundation, how the Docker architecture is there, how exactly the Docker images are created. All those, if you know in detail, and see, whatever I have shown is a very basic project, right? In real-time projects, what will happen? We like these JSON files. In my project, I have 18 files. Okay, what these 18 files will do is startup docker.sh will be there. Then after that, once the startup is done, then I will check the configuration one. So this startup, what it will do is I will just check whether all the EC2 missions are up or not, all the health checks are there or not. That is the only one. So after this one, at the end line, I'll trigger one more file. So then I will check the configurations, whether all the configurations of our production servers or UAT servers are correct in exact version or not. Then after that, then we will have the softwares to install, sorry, the one Docker file to install web servers. Then I will have one file to install databases. Then I will have one file to take the code commits, both for dev code and test code. Then I will have one file to execute all the network configurations and application configurations. So in application configurations, I will have for Chef and Puppet. Okay, so then later I will have a wind up script. Okay, in the wind up script, I'll check whether for every file, right, I'll have a health check. Okay, will be generated. I'll check whether all the files has been okay or not. So this is my entire file. So I how many files I have? I have 18, but I didn't brief all those. So let's assume 1, 2, 3, 4, 5, 6, 7, 8. 8 files I have, right? So for this, if I want to build these 8 files, I will not build everything in parallel. So for every file, I'll create a Maven project, which will have a pom.xml. Okay. Using this pom.xml, I will execute this file, check whether everything is done or not. Then using this pom, I'll check and whether so I will have 8 pom files, which will outside of the project, I'll have single pom file. I'll trigger only this pom file where I will have configuration for all other pom files, so that everything will be automated. This how complex. So this is also a simple one, which we have created in very simpler way. I have seen my friends' project, which are 10 times complex of this one. So all this you will learn only when you spend at least minimum 8 to 9 hours of training in Dockers. Once you spend this one, then ECS it's a cakewalk for you. So everything will be self-explanatory. So you will know what are the configurations inside the JSON, what you need to provide, how exactly control your memory, how exactly control your CPU usage, and other metric values and all. So you will be expert by the end of this course. And also other concepts like Docker's fan is there and Kubernetes is there. You need to learn those both also. So 8 to 9 hours is required to complete Docker's fan and Kubernetes. Okay.
Okay. Harish, one more last doubt. Like
Yeah.
when we spin up an instance, EC2 instance, and after installing a Docker over there, if I want to pull an image from the AWS ECR,
Yeah.
what is the procedure? Like
So this is
by
the
default, if I
procedure.
pull,
Yeah, this is
no,
the
by
procedure.
default pull, if it goes to docker.hub.dockers, right?
No. By default, it won't go. So I just shown you the example before AWS. Why I have shown you is, so you need to understand. Yes, there is an outside one more repository, which is a Docker's repository. This is a AWS repository. So to make that concept clear, I have shown this one. So if you want to directly take from ECR, right? So go to your services, go to your ECR. So in your ECR, they will show you all the pull commands. So say for example, this repository you want to pull, right? Click on the target repository. Here you can view the commands. So using these commands, you can see everything. So this is for push commands. For pull is just Docker pull and what is the image name, image of that particular Docker. So that you can get it here, image URI. Docker pull, and if you give this image URI, and if your Linux mission, whatever you have taken, which has a valid IAM role access, right? For this ECR to pull this one, definitely it will be get pulled. So let me show you here. Docker pull. No basic auth. Oh, okay. Okay, this is this one, right? We have configured here. Docker pull. So if you see here, the latest one is pulled. So if you check Docker images, so you can see this is the one which you pulled from ECR. You can see here, right? This is the image ID.
Okay.
So questions?
Harish, earlier
Yeah,
you were on a different,
yeah,
you got the authentication error.
yeah.
You
So
were
why?
on a different.
Correct, Namita. Why? Because we have configured AWS CLI in this mission, the
Yeah.
initial mission which we took, but this mission doesn't have any role, right? So that's
Yeah.
why if you configure the same role, AWS
Yeah.
configure. I guess it's single command. I guess CLI is not there. So this AWS CLI is not installed here.
Yeah, understood, Harish.
Yeah, guess we can enable it.
I think since it is a container.
Container one, they removed CLI here.
Yeah, might be there.
Yeah, one thing you can check. Yeah, so no containers, only core and extras are there. So CLI container is removed here. So if you want, we can install AWS CLI. And one thing, when you're trying to practice the lab, right, for Docker's lab, if you are installing normal Dockers, if you take any Ubuntu missions like that, Ubuntu missions will not come default like this. It will come like a plain mission. It will come. It will not have AWS CLI command. So for that, you need to install using pip commands. Okay, AWS CLI in Linux too. And the CLI version 2. Okay. Okay, I guess we saved in Notepad.
No, I think you took it off that time.
Okay, we can get it from here. So yes, IAM roles. What do you remember the username? User. This one, right? Today, yeah.
Yeah.
So if you go to as you know, right, secret key will be shown only once. Now, how to get secret key? So this is a good opportunity to show you people. The same secret key we used in Linux mission. This Linux mission, right? The Docker, our managed Docker's mission. So here you can go under CD. Sorry, can.aws. it will be under credentials. Cat credentials. So secret, these are your secret key. Okay, this will paste in this mesh. US-east-2 table. Yeah. So if you want to pull inside this one, this is the pull command. No basic auth credentials. Okay, so we also need to configure this one. So go to your ECR, push commands, this. Login is there. Login succeed. Now you try this command. Yeah, if you see here, Docker images. So this is the one which you downloaded. Okay. Any other queries or doubts?